Our lecture for today is to show that the behavior of a capacitance in an AC circuit is analogous to that of a resistor which obeys Ohm's law, and hence to measure capacitance. What is a capacitor? An electronic component that stores an electronic charge and releases it when required. Consisting in general of two metallic plates, separated and insulated from each other by a dielectric. It comes in a huge variety of sizes and types for use in regulating power as well as for conditioning, smoothing and isolating signals. Capacitors are made from many different materials, and virtually every electrical and electronic system uses them. This photo shows us how the capacitor look like. A capacitor, occasionally referred to using the older term condenser, is a device that stores energy in the electric field created between a pair of conductors on which equal but opposite electric charges have been placed. Intentional capacitors have thin, conducting plates, usually made of metal, stacked or rolled to form a compact device, but every multi-conductor geometry has capacitance. Physics of the capacitor. Capacitors act like tiny storage batteries. Typical designs consist of two electrodes or plates, each of which stores an opposite charge. These two plates are conductive and are separated by an insulator or dielectric. The charge is stored at the surface of the plates at the boundary with the dielectric. Because each plate stores an equal but opposite charge, the total charge in the device is always zero. Capacitance. The capacitor's capacitance, C, is the measurement of the amount of charge, Q, stored on each plate for a given potential difference or voltage, V, which appears across the plates. C is equal to Q over V. In SU units is farad. Since the farad is a very large unit, values of capacitors are usually expressed in microfarads, μF, nanofarads, NF, or picofarads, PF. The capacitance in the electric circuit in the case of a constant voltage, DC, equilibrium is soon reached, where the charge of the plates corresponds with the applied voltage by the relation Q is equal to CV, and no further current will flow in the circuit. Therefore direct current cannot pass. However, effectively alternating current, a C, can. Every change of the voltage gives rise to a further charging, or a discharging of the plates and therefore a current. The amount of resistance of a capacitor to a C is known as capacitive reactance, and varies depending on the AC frequency. In DC circuit, it acts as open key. In a C circuit, it acts as close key. Capacitive reactance. Capacitive reactance is defined as Xc is equal to 1 over 2 pi Fc, where Xc is the capacitive reactance in ohms, F is the frequency in hertz, and C is the capacitance in farads. Capacitor networks. Capacitors in a parallel configuration each have the same potential difference, voltage. To find their total equivalent capacitance, CEQ, we need to add the values of each of them. The current through capacitors in series stays the same, but the voltage across each capacitor can be different. The sum of the potential differences, voltage, is equal to the total voltage. To find their total capacitance, CEQ, we need to add the values of reciprocal function of each of them. The medical applications of capacitance. 1. In capacitance method of short-wave diathermy, it is considered one of the methods that are used for transferring the electromagnetic energy into the body in short-wave diathermy. In this method, the part of the body to be treated is placed between two metal plate-like electrodes energized by the high-frequency voltage. The body tissue between the plates acts like an electrolytic solution. The charged particles are attached to one plate and then the other depending upon the sign of the alternating voltage on the plates. This results in resistive, Joule, heating. Different body materials react differently to the waves, and this effect provides some selectively in treatments. 2. In pulp tester, a system for testing the dental pulp of a tooth by electrically stimulating the pulp with a pulsating signal. The pulp vitality test is a method for pulp examination through admission of fixed increased by amplitude electrical impulses. The electricity passes through hard dental tissues and causes irritation into pulp's nerve receptors. 3. In other medical devices,